Hi, welcome back to the Shiko Math Practice Lab and Algebra 2 lecture series. So we are continuing on the chapter 2. And so in this video, we're going to talk about the special function. So one of the special function we're going to talk about in this video is the piecewise function. So what is piecewise function? So piecewise function will just tell you, instead of the one domain, you might have 2 or 3 domains. Then for each domain, you have a different function defined in each domain. Then when you combine all the domains together, that is the function. So that's what we call it, the piecewise function. So let's take a look at our worksheets and then let's try to do a couple problems, show you what is a piecewise function looks like, okay? So I'm going to go to the worksheets here. Okay, so for these worksheets here, so we're going to talk about the piecewise functions, and I'm going to, here, let me go to enlarge this one a little bit, and so it'll be easier for us. Whoa, this is too big. So it will be easy for us to graph so we can see better here. So, okay, I need to shrink it a little bit. Okay, so here, okay, so that's good. Okay, so first we say the piecewise functions, right? So that means if you take a look here, and so if you take a look here, the piecewise, that means you know, we have the domain into a 2. So the first one is when x is less than -2, then this is your function. And then the next one's here. Okay, so hold on. I think I just accidentally, you know, hit the stop sharing button. Okay, so then the next one's here. If you take a look, this piece is here. Right, so this is for the different domain range, x is greater than -2, see here. So when the time, you know, that's why we have 2 different domains here, and each domain, the function is different here. Okay, so one of the key things here, when we want to take a look, what is the piecewise function looks like? So we're going to look at where it breaks here. All right, so this is the where it breaks here. So it's x equal to the -2. Okay, so when I try to graph it, okay, so let's try to see how we graph it. So the first ones here, I'm looking for the ranges here, right? So the first ones here, I'm looking because it's x less than equal to, right? So I'm going to have like the -infinity to -2 here. So remember, I always want to plot the -2's here, right? So from this range, for these domains here, my function is x plus 2. So let's try to graph it. So remember, right? So we say we always graph the point at the breaking points here. Okay, so now you will say here, okay, so this is x value, this is your f of x values here. So when x equal to -2, what I have here, I have what? I have 0, right? So x equal to -2, I have 0. So let me use a different color to graph it. Okay, so x equal to -2 is 0. So I'm going to have this point. And because of here, this is the equal signs, right? So I'm going to have what? I'm going to have a solid, correct? Okay, so because this is a linear equation, so we need to choose other points. So like in here, you can choose any other one you like. So like I said, how about if I choose -4? Okay, so if you choose -4, what is this function? -4 plus 2 is what? -2, right? Okay, so you have 2 points. Then you can what? You can graph the lines here. So -4 is here. Then I got is -2, so it's here. Okay, so now you can connect these 2 points. So this is the lines, right? So this will be the line here. So remember, right? So this is the one you have to put the solid. Okay. Okay, now let's take a look at another piece. That's what we call this piecewise. You just need to look at each piece here. So this is 3x, right? So the other piece is 3x. And it's running from the -2 because to the infinities, right? So let's take a look again. So this is f of x. This is x and f of x. So remember, right? Even this is the is the parenthesis. So I'm still need to put the -2 inside my function to see what it looks like. Okay, so this is -2. So when x equal to -2, what is this one here? This is -6, right? Okay, so this is -6. So now I'm going to graph it. Okay, so -2, so it's -6 is 1, 2, 3, 4, 5, 6. So here is a what? Here is a circle because there is no equal signs here. Good. Okay, so now you can choose any other points here. So I would choose, hey, let's choose 0. See, it's easier. Okay, so 0, so this is 0. Okay, so now I have the other points is in here, correct? Okay, so now you connect these 2 points, you can get a line here. Okay, so that is what is this piecewise function looks like. All right, and now, okay, so you always break it, right? So you always choose one point. So where is the breaking point? Okay, so now let's take a look at domain here, right? So for the domains here, let me see here. So, okay, so the domains here. Okay, so the way you look at domain, so basically you're going to kind of is the L. What is the axis here, right? So the way you typically look at it, you just use a line, kind of have lines here. So let's see here, you have lines like go through. So you kind of have a line go through like the X direction, like the X direction to see is every point got covered. So like in here, you say, yeah, seems all the points get covered, right? So here, so now if you take a look here, you say, how about this one's here? So like in here, yes, it's still got covered. Even this is a circle, but we have a solid value here. So I know this one's get covered. So what is my domains here? Domain is what? So the domain is equal to what here from the negative infinity to positive infinity, right? So it's all real numbers. All right. Then for the ranges here, so the ranges here is the same things. So the ranges here is the same thing. You kind of do a Y lines here to see is every point get covered from the Y direction. So you can see here, you say, okay, this one's here, right? So it's got covered. How about this point? So this point is got covered also because why? Because these green ones continue going here, right? So that's why, yeah, like I do have a point is defined in this function. So that's why the range here is also is what? It's negative infinity to positive infinity. So both of them, is belong to this, the whole real numbers here, right? So that's how do you find the domain and the ranges here, right? So the key point is, what is the key point? Remember, when you do the graph, what you do here, you always do it at the breaking points, right? Okay, let's take a look at the second one here. So the second one, right? So the first domain is x greater than 0. Okay, so then your functions here is 4 minus x. And the second one is here, the second domain is x less than 0, so it's negative 2x minus 2 here. Okay, like we talk about, we always going to do what? We're going to break because they break at the zeros, right? So we're going to break at the 0 point. Okay, so now let's see here. The first one, x greater than 0, there's no equal sign. So I know my function is from 0 to infinity. And my functions here for the first domain is 4 minus x, right? So let's choose the point. So this is x, this is f of x. Remember, we always do the breaking point. correct? So this is the breaking point, right? So I need to, first one, I always need to have a breaking point. So let's choose 0. So when x equal to 0, what is f of x? It's a 4, right? Now you can choose any other point. So let's choose what other point we want? Oh, let's choose 4. How about that? Doesn't matter. You always get the same thing. So when x equal to 4, what is f of x here? Is 0. So that's pretty good. So let's try to graph the first piece. First piece is 0, 4, 1, 2, 3, 4. And in here, we need to be careful because it does not have equal sign. So what you have here, you have a circle. Got that? Okay, so now the next point here is 4, 0. So 1, 2, 3, 4. So it's in here. And then you connect these 2 points. Right? So you get a line here. Get that? Okay, so you connect 2 points and this line, I did not draw too well. Okay, so you connect, so you got a line here. Okay, now let's take a look at the second interval. Second interval is x is less than 0. So that means from 0 to infinity. And what is my function? My function is negative 2x minus 2. Okay, so let's do again. So this is x, this is f of x here, all right? Okay, so remember we always do at the breaking point. So what here's the breaking point. So I need to always find the breaking point. So I put the zeros here. Okay, if you put the zeros here, what is here? So this is what? It's negative 2, right? Okay, so this is negative 2. So let's try to find another one. How about let's choose negative 1. Okay, if you choose negative 1 here, so it's negative 1 times negative 2, it's positive 2, right? So the positive 2, and what do you have here? You got a zeros here, right? Okay, so now let's try to graph it. Okay, the first one is 0 and negative 2, 0 and negative 2. Also, this is what? This is a circle, right? Because it does not have what? It does not have the, the equal sign. Then the next point is negative 1 and 0. So negative 1 and 0 is here, right? Okay, so now I can, I hope that I can do, okay, so this one's here. I connect these 2 points, I can get it. So this is what? This is my piecewise functions. Here. Okay, now let's take a look at domain. Okay, so the domains here. Okay, so domain, like remember, you go to the x direction to see, you do the lines here to see every line can be covered by the graph. So it looks like okay, right? Except what? Except this one when x equal to 0. So for these ones here, both graphs, since they're going to have a circle, is not covered. Right? So I know the domains here is what? So the domains here is from negative, okay, so it's from the negative infinity to 0 and 0 to the positive infinity, right? So the 0, so this point here is not included. Okay, so then the same way is here, right? So the same way, like if I want to find the ranges here, right? So the range, you go like this way to see if each one can be covered by the graph. So the first circles here, it cannot be covered by the green one, but can cover by the red one. So it's okay. So you continue to see, always can be covered. Now, okay, so these ones here, right? So these ones here, cannot be covered by the red one, but the green one is covered. So I know what happens here, the ranges here is what can be covered everywhere, right? So what is the range? So the range is from the negative infinity to the positive infinity. So it's all the real numbers here. The graph cover the y-axis from the negative infinity to the positive infinity. So the domains here cover the x-axis, right? So the only part here is not covered, right? So just like we graph here, the only part is not covered with these lines, right? Because they both have circles here. Okay, that's it. That is what we call this piecewise function. So it's pretty simple. So it's really is just you have several different domains. Now, under each domain, then the function have a different function. So the way you do it to graph it, so the key point is you graph under each domains, right? Then you always graph the breaking point. So where is the break? Like a second example, to break at 0. First example is break it at 2. So you always break it. Now you just watch it to see they have equal sign or they don't have equal sign. And then, if equal sign, you put a solid dot. If it's no equal sign, you put a circles here. And then that's it. That's what we call this piecewise functions here, right? So just be careful, and that's it. Okay, so that's it about this video and about the piecewise function. It's pretty straightforward. So just remember that, right? So when you do the graph, you always include the breaking point, then you choose any other point, right, to graph it. That's it. Okay, so it's nice to talk to you. You have a good day, and hope to talk to you on looking forward to talk to you in our next video. We're going to talk about another very special function. We call it the greatest integer functions here. Okay, bye.